Hey guys, this is a video for 8th grade math, lesson 102, and so this is Tuesday of the second week. But what I'm going to do in this next 4 days is I'm going to actually record them all the same day. So obviously you can't follow my YouTube growth or anything like that, but I know that this channel is blowing up, so keep liking it, keep subscribing to it, and all that good stuff. Raid Shadow Legends is surely coming to sponsor a video soon enough. Obviously not this week. But, again, I don't know what's going to happen next week. So I'm going to just finish the week of the videos. And then, obviously, I will know while I'm doing Google Classroom whether or not we're going to go back to school the 30th? Right? Because the 27th is going to be this Friday. And so 27, 28, 29, 30th. Yeah, the 30th. We will. I don't know right now while I'm recording, but obviously I will know throughout the week. And so if we don't go back to school the next week, it's going to be crazy. Because then we were going to do from lesson 106 to 110. And that would mean that we would have 10 lessons left to go for the whole year. That's it. That's 10 lessons. So right now, as I speak, we're going to do lesson 102. So not counting this lesson, if I finish this lesson, because you're obviously watching it, we'll have 18 lessons left. So at the end of this week, we're going to have 15 lessons left. And if we have another week of this, it's going to be 10 lessons. If it gets extended by another week, then we will have 5 lessons. And that would be just five more lessons and we're done. So I don't know what's going to happen. But what I'm going to try to do is, if we are going to continue doing the videos, then I'm going to just do the videos every day until we finish the book. If it happens that we finish the book before we go to school, before we get to actual school, then there is no problem, because all I'm going to do is I'm just going to ask you to review, to ask me questions, to do whatever you have to do, and I'm going to be keeping on a lookout to see when we get back to school, and I'm going to give you the lesson numbers for the different tests that we would be taking, because even if, for example, worst case scenario, that we don't have school the rest of March, and we don't have school in April and come back in May, I would be done with the book way before we even get to May. If we keep it at this rate, I think by the second week of April, I'm done with the book. So, yeah, I don't know. So one of the things that I have to tell you is that I don't want to worry about the test, because I don't really have to worry about the test, because even if they just allow us to come back to school in May, I can spread them out, and you would still have a pretty good time of not having to take a lot of tests, but your lessons would be done. Okay, so that would be something quite remarkable, which could happen. So I don't know yet, but let's get into this lesson. 102, which is growth and decay. And before we do that, I'm going to talk a little bit about investigation 10, which is going to help us in here with something called the rule of 72. So before we turn to lesson 102, I wanted to turn in your book to page 673, which is going to be investigation 10. All right, so the rule of 72 says the following, that we're going to have 72 divided by the growth rate. It's a percentage, right? And then that would equal the doubling time, how much time it would happen. And so they actually tell you, okay, make sure in an example they ask you, you can look at in the page that I told you, 673, it says that in how much time would it be until an investment doubles at 6% interest. So what we do is we put 72, we divide it by 6, don't just take the percentage out, don't worry about anything else, and it would give you 12. So what we're going to say is that about in 12 years, my investment is going to double. And it doesn't matter how much money I have put in it. That's why it didn't even tell us how much money. But let's say you put $1,000. In 12 years, you will get $2,000 if it's a 6% interest, which is obviously not very good. But if you put $10,000 in 12 years, you can get $20,000, and if you put $100,000 in 12 years, you get $200,000. So this is a rule of thumb. A rule of thumb is like a little trick sometimes in math that helps us. Now, I had to talk about this because in growth, it would actually help us. This is actually very helpful for growth. So let's actually get into the lesson, into example 1, which is growth, okay? And growth has to be like percentage, all right? Like the percentage growth of something, okay? And decrease is the same. So example 1 says, in a country there is 1,200,000 people, and the annual growth rate, or how much it grows every year, is going to be 2%. So each year is going to grow by 2%. And so the question is, in 3 years, how much will it grow by? And you have to estimate your answer to the nearest thousand, okay? And then they ask you, if we use the rule of 72, in about how many years will it double? So I'm going to actually start with the rule of 72 because that's what we just talked about. And so we're going to do 72 divided by 2 is going to be 36 years. It's going to take it 36 years for that country to go to have 2,400,000 people. All right. That's a 2% growth rate each year. That's why it will take it about 36 years. Now, let's actually do the harder part of the lesson, which is the growth by 2%. Again, can we do math with percentages? No. Then why do we do the rule of 72? Because the rule of 72 is different. It's only for growth. It doesn't work for decay. It's only for growth. And we only use the 2% like that. But only in the rule of 72. In any other problem that we have to use percentage, we cannot use percentages. We cannot. We have to change it into a decimal or a fraction. So in here, we're going to change it into a decimal. Now, understand something. When you do it into a decimal and into a fraction, or a decimal or fraction, especially for tip, for example, if they're asking you for 10% tip, all right, for 10% tip of a $10 bill, not the bill like the one you take out in your wallet, but the bill that they show you at a restaurant. So let's say it's an even $10 that you spent, and they say you have to give us 10%, okay, of that as well. So 10% of $10 is going to be $1. So are you going to pay $1? No, I don't think so. You have to pay $11 because you have to pay your bill plus the 10% that they're asking of you. So that's $11. So what you did was you added at some point. So first you multiply by 10 and then you add it. Well, I'm going to say that because all problems relating to percentages, you have to multiply and add or multiply. I will make that case, okay? So my case is that in the first case where you paid $10 and then they charged you 10% of that, which is going to be $1, then you add it, 10 plus 1, and then you added it. So first you multiplied $10 by 10% and you got $1 and then you added it, okay? So all those cases you have to multiply then add. But I'm going to say, wait. Why don't we add first and then multiply, making it easier? What am I talking about here? What I'm talking about is that if the growth of this country was by 2%, okay, they're not telling us what was 2%, what is 2% of this? No. They're telling us by how much did it grow. So in this right here, this is 100%, right? Everybody understands this is 100%. But at the end of the first year, it would not just be 100%, it'd be 102% the year after this. Because it grew by 2% and it was already 100. So what I'm going to do is I'm going to add the percentages first and then multiply. And that's my strategy to do this. So what I'm going to do is I'm going to actually make it a lot simpler. Because they say multiply to the nearest 1,000. I don't really care about the last three. So I'm going to cut it into 1,200 and then I'm going to multiply by 1.02 because that is 102% is as a decimal, right? Hopefully everybody can see it there. And so I'm going to just multiply 0, 0, and 2 is 4, and 2 and 1 is 2. And then 0, placeholder, 1, 2, 3, 4. Then 2 placeholders, then 0, 0, 2, 1. Then I'm going to add all together. So this is 0, this is 0, this is 4, this is 2, this is 2, this is 1. I had 2 decimals. And it becomes 1,224,000 people at the end of 1 year. I'm going to multiply that again by 1.02. I'm going to forget about these 2's because they don't really matter anymore. So I'm going to multiply that. So it's going to be 8, 4, 4, 2, placeholder, 1, 2, 3, 4, 2 placeholders, 1, not 0, sorry, 4, 4, 2, 2, 1. And I'm going to add together 8, 4, 8, 4, 2, 1. 2 decimals. So at the end of my second year is going to be 1,248,480 people. But this doesn't count. However, this time I'm not going to stop it because what if I multiply once more and it ends up being important. I'm also labeling my years so I know what I'm doing. All right. So in my first year, I got 1,224,000 after the first year. After the second year, I got 1,248,480. Okay. After the third year, I'm going to get 8 times 2 is 6, and a 1 goes up. 4 times 2 is not 8, plus 1 is 9. 2 times 8 is 6, and a 1 goes up. 2 times 4 is 8, plus 1 is 9. 2 times 2 is 4, and 2 times 1 is 2. And so I get 0 as a placeholder, and I have 1, 2, 3, 1, 2, 3, 4, 5, 6, 6. 1, 2, 3, 4, 5, 6. You see why I didn't want to have all the zeros here? It just makes it way too long. And then I have 2 placeholders. And then I'm going to multiply by 1. 8, 4, 8, 4, 2, 1. And I'm going to add all of that together. And I'm going to get 6, 9, 6 and 8 is 14, and a 1 goes up. Again, 14, because 10 plus 4 is 14, and a 1 goes up. That would be 13, and a 1 goes up. That would be 7, 2, 1. How many decimal places? 4. 1, 2, 3, 4. So finally, I get, at the end of the third year, I get 1,273,449.6. That's going to be at the end of the third year. But remember that we only care until here. So the approximate answer is going to be 1,273,000 people that were born. The 500, we're going to kind of not care about it, but that's it. I got the same numbers. And by the way, I used 3 less zeros than the ones in the book because it's just a lot of work. But that's the growth, okay? So that's how you do it. Just remember, it's like tip, okay? It's like estimating tip is like what we've been doing with money. So I don't think it's very hard. And the rule of 72 is pretty self-explanatory if you understand that it's a rule of thumb. It's something to help you out to find how much time it would be until it doubles. All right, for the second example, they're actually talking about carbometric dating. It's something that I don't know if you're doing with PASPAT this year or if you did it last year, but I know that the 8th graders already should know about carbometric dating, which is something that science, according to science, they say that that's the way that they can actually find that fossils are millions of years of age. But we understand that that's a lie. That's actually not true. And so half-life is the amount of time it takes for something to lose half of the amount of molecules of something, of a certain element. And so they say that, for example, in this example, they say that for carbon-14, the radioactive isotope, the half-life is about 5,730 years. I don't know how they came up with that number, but obviously that's not true. I actually saw a study in which they did the half-life of people who had died in like the 1900s. And they said that they had died thousands of years ago. And obviously they died about 120 years ago. So I don't understand how they do that, but you know, that's science for you. But anyway, in this particular example, I'm not going to do it on the board because I have to kind of explain to you what it means. So hopefully you understand that the half-life, so it means that if there were 100 particles of carbon-14 atom, it took 5,730 years to become 500. All right, so to go from 1,000 to 500, it took 5,730 years. So it says, if a bone is found containing about 1/4 of the amount of carbon-14 as a modern-day bone, about how old is the bone? So what you have to do is you have to do half. So it would take 5,730 years to become 500, but then to become 250, it would still take about 5,730 years, because what they're saying is, okay, so it takes about 5,730 years to become 500 particles of carbon-14, but to become half of 500, it would take you, literally, it would take you still 5,730 years. So what happens is that it's a decay that's exponential. It's not something that you do half of half. No. You actually add it twice. So you have to say, okay, to get to 500, it took 5,730 years. And to get to 250 molecules of carbon-14, it would take you about another 5,730 years. So if you add them together, that's about 11,000 years, and that's why the answer is A. Now understand, for the decay problems, because they're a little bit harder to comprehend, we are not going to ask you to actually do a lot of math. It's going to be more estimating and stuff like that. So if you have any problems, please let me know. But this is it for lesson 102 for Math 8. So I will see you tomorrow.